already shown how to change weights in the output layer like W prime 1 1, and now we are trying to show just a schematic of how to change weights in the hidden layer, okay, like the weights going into the hidden layer. Let's say W11, okay, once we can do one, we can do the others also. So this is a little bit kind of deeper because it's in the chain, it's much more backward, so we have to do many more partial derivatives and the chain is longer. So how to do that? So we know that the total the error is also, the error is also called loss or cost function, okay. So so you see E total is the error in here EY1 and the error in the second output neuron, which is EY2. So we have written the error total is basically EY1 plus EY2. Now, if we take partial derivative of them, so with respect to W11, which is this weight, so this is basically comes down to this. So we have to separately calculate this the first term and the second term and add them up. Okay, that's the objective. Now I have written the chain here that EY1 depends on the output of layer Y1, which depends on the input, which depends on the output of this first hidden layer, and which depends on this weight. Okay, so this is the CE Y1 depends on Y1 out, which depends on Y1 in, which depends on H1 1 out, and which depends on H1 1 in, and which depends on W1. You can see it's a long chain. Exactly similarly, so for EY2 also we have to do, because you can see that this weight affects both the outputs, right? So this goes into both this neurons and affects both of them. So when we try to change, so we have to consider both of them. And now you see Y2 is depending on Y2 out, which is this, and then Y2 in. And now we will go back to this one, okay, because this weight is coming to affect that weight. So this part we can ignore. So now you see this one is being affected by this weight W prime 1 2 and the outcome of H1 1, and in that way, okay. So we have done that to show H1 out and then H1 in and then W1 1, okay. So now you see just this one I have shown how to calculate the partial derivatives and what will be the values. So if we take del EY2 del W11, this will be the different partial derivatives, okay? And we multiply each of them to get the final value, which is for this one. And what will be the values of these partial derivatives I've just written here is Y2 out and the expected value, okay? Whatever the actual we are getting and minus the expected one. And then for this, it will be the in and out. It's the activation function. When you do the activation function, if it's a sigmoid function, then this is the formula Y2 out times 1 minus Y2 out. This is just for the sigmoid function, please remember. And this is for W prime Y1 2, if you because this will be this input formulation, and if you take the derivative of it. Similarly, this is again activation function. So if it's a sigmoid function, this will be the derivative, partial derivative. And if you take for this one, this input with respect to W11, so this equation, the linear equation, then you get this one, which is x1. Because x1 times W11, if we take W11 as the, with respect to W11, then what we are left with is x1. So we have to multiply all of them and get the value for this. So you see, if we do, we will do the similar thing for del E1 with respect to del W11, okay? So we'll do, and many of them like this one and this one, they will actually have the same values for partial derivatives. So this is one good thing about going deeper in a neural network backpropagation. So many of the partial derivatives values are usable, okay? So as I said, this one are same, these two are same. So basically, once you calculate, you can reuse it. It's very very useful and reduces the computation cost. So standard formulation, once you know the activation function, it's pretty easy actually, although it looks daunting and complex, but it's not. So once you have del EY2 with respect to del W11, and similarly for this, we can sum them up and get the slope of this, the outcome, the total of the outcome with respect to del W11. That means with a little bit of change in W11, how the error is changing. Okay, so now we have to calculate the new value of W11 using the gradient descent formula, and we know that formula, the new value of W11 is the old value minus the landing rate times the slope of the curve, which is calculated using that. And this it will give us the new value of W11. If we are in the negative zone in the left side, it will be added, the W will increase. If we are in the positive zone, it will help W to reduce, so that in that parabolic curve we can come to the middle point, the minima. And in this way, back propagation works for the hidden layer. And you can see the deeper and deeper the network, there'll be more and more reuse of many components, and the computation, although costly, will be able to utilize from its previous values.